class, how are you doing today? That's great!
Alright, so the learning target today is to prove that two lines are parallel. Last class we determined if two lines were parallel. And so now we're going to prove it. The difference is determining is being able to figure out that it is. Proving is showing why. So it's a lot of explaining your answers, but there's a specific way to do it, and it's going to be using what's called a two-column proof. The scale for this lesson is a 3. You can prove that two lines are parallel. 2, you can prove that two lines are parallel, but you have trouble with the reasons for the step, the explaining why. 1, you can determine if two lines are parallel, but you can't write a proof. And 0, you cannot determine if two lines are parallel. Let's get started. So when you write a proof, a two-column proof, one column is your statements. You say things that are true, like something is congruent to another thing, or that two lines are parallel, which is usually the end of it, which I'll get to. And then the reasons is why those things are true. You can't say something without backing it up. So in a two-column proof, you're going to have lines going across, and each line will be a statement and then the reason why that thing is true. And then another statement and then another reason why that thing is true. And so on and so forth. So the two-column proof is split up into 3 parts. And they can each take a different amount of lines, but the first part is your givens. Things that are automatically given to you at the beginning of the proof. And you can easily identify those things by, at the beginning of the proof, it'll say, this is given, prove this. So the things that are given will be what you write first. So whatever is given, you will state as, whatever the reason is, as given. For all of them, no matter how many there are, whether there's 1, 2, 3, 4, you'll write given in the reason. The next section, again, it'll take a different amount of lines every time, but that is your body. The body of the proof is going to be the most difficult part of the piece. And whatever the statements you come up there, it's the things that get you eventually to the conclusion. You have to say other things before you get to the final part. And the reasons can vary, and I'll give examples of reasons in a moment. But that's where you'll put all those different kinds of reasons. And then the final part is the conclusion. Usually is only one line. And in the conclusion is where you will say that, in this case, the two lines are parallel usually. They may be looking for something else, but in this case they're probably looking for the fact that the two lines are parallel. Okay? So in this case your end statement will probably look something like BD is parallel to AC. And then your reason will probably be corresponding angles. Something to that effect. It'll probably be one of the theorems that we just learned about in the last few classes. Alright, so here I'm going to put a list of reasons that you may use in your proof somewhere. These are the ones that will most likely come up, but will not all of them I can put in here, because there could be one I'm not thinking of. There are really infinite possible reasons. I'm just going to put the ones that you'll more likely see. One property is the reflexive property. And what that says essentially is AB is congruent to BA. The line segment is congruent to itself, it's just written differently. It's possible you may need to use that one just to state that something is congruent to itself, but it's written differently. Next is the transitive property. If angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3, then angle 1 is congruent to angle 3. So, what that means is, since angle 1 is congruent to angle 2 is congruent to angle 3, angle 1 is congruent to angle 3. So, transitive property works that way, where you can just plug things in like that. And notice, this is an if-then statements. Many properties and theorems work that way, where they're conditional statements. If-then. Next is the substitution property, which you may have dealt with in algebra a bit, but it's used again here in geometry. So this is more of an example here. You can use the substitution property in so many different ways, but here's an example I used. I took and said angle 1 is congruent to angle 2. If that's true, and say some other statement, angle 1 plus angle 3 is 180 degrees. Then you can replace or substitute angle 2 in for angle 1. So angle 1 then becomes angle 2 because of the substitution property. And some more of these will be more like statements of things you know. A big one that's used is vertical angles are congruent. So these are, if you have two lines that intersect each other, the opposite angles are vertical angles, and those are always congruent. Next one is that right angles are congruent. So if you have two right angles here, they are congruent. So right angles are always 90 degrees, therefore they're congruent. A lot of these may seem like a little simple, a little common sense, but in a mathematical proof you do have to state that kind of thing. Alright, the last one I'm going to talk about is definition of blank. I put the blank there because there's an endless amount of phrases that you could put in for that blank. It's definition of things that we've learned in geometry, whether they be perpendicular lines, angle bisectors, midpoint, perpendicular bisectors, segment bisectors. Definition of blank will get you to a spot. If they say like angle 1 and angle 2 are perpendicular angles, you can then say that both of those angles are 90 degrees because definition of perpendicular angles. So whenever it says something is something, you can say definition of blank to then state what that means. And I know I said that was the last one I was going to tell you about, but here's another one. A linear pair. If you have two angles that together form a line, they're a linear pair, and you have, so angle 1 plus angle 2 in this case, equal 180 degrees. Alright, and keep in mind also possible reasons are any of the theorems that deal with parallel lines. You'll mostly use them in your conclusions, but you may also use them in your reasons themselves. Alright, so here's one problem. You're given that angle 1 and angle 5 are supplementary. Remember, that means they add up to 180 degrees. They want you to prove that line L is parallel to line M. Remember, two lines together like this mean parallel. So line L parallel to line M. So you have to make a two-column proof. So you start by making your first statement, which was given to you. Angle 1 and angle 5 are supplementary. That was given to you, so the reason is given. Then from there, you have to do different things to try to get it to prove that line L and line M are indeed parallel. So there could be a couple ways to go about this, but what I'm going to do is, I noticed to angle 5, we've got angle 3 here. So, and those two make a pair for parallel lines, so we can deal with that. I think that'll work the best. So, well, angle 1 and angle 3, we know are vertical angles. So since they're vertical angles, that means they're congruent. So we can say angle 1 is congruent to angle 3. And the reason for that is vertical angles are congruent. So now that angle 1 and angle 3 are congruent, we can say that angle 3 and angle 5 are supplementary. And the reason for that is substitution. Because since we said angle 1 is congruent to angle 3, we substituted angle 3 for angle 1 to say angle 3 and angle 5 are supplementary by substituting it in. So using the substitution property, we can say angle 3 and angle 5 are supplementary. Now from here, angle 3 and angle 5, this kind of pair, they are same side interior angles. So same side interior angles we know are supplementary. So we can say since angle 3 and angle 5 are supplementary and they're same side interior angles, we can say that line L and line M are indeed parallel. So we say line L is parallel to line M, and the reason is because same side interior angles are supplementary. So we've just gone through the steps to prove that line L is parallel to line M. Alright, so now this one's backwards. We're given that two lines are parallel, T and H. We want to prove that two angles are congruent, angle 3 and angle 6. So, from there, we look at this picture over here, and we have to write a two-column proof. So just like previously, start with what you're given. T is parallel to H, and the reason is given. Then, knowing that T is parallel to H, we have to say that angle 3 is congruent to angle 6. Again, in this problem, there's a few different ways you can go about this. I'm going to pick the simplest way I can find. If you have other ways, that's perfectly fine as long as you get the correct proof. So, with this, we can say, since T and H are parallel, we want to look for the kinds of angles we deal with. Whether they're corresponding, same side interior, alternate exterior, same side exterior. Those kinds. So, Looking here, we can see, let's use one of our angles we have so far. Let's use angle 3. And what's something that the other one is close to? Well, let's look at angle 8. So angle 3 and angle 8, these two are congruent. And the reason for that is because they're corresponding angles. Then from there, we have angle 8 and angle 6 are also congruent because they're vertical angles. Then finally, we can say that angle 3 and angle 6 are congruent because they are or rather because of the transitive property. Because before we said angle 3 is congruent to angle 8 and angle 6 is congruent to angle 8, therefore we can say angle 3 is congruent to angle 6. So now we just proved that angle 3 is congruent to angle 6. As I said, there are different ways to do it, and while doing this problem, you probably noticed that there is an even simpler way, but I wanted to get some steps into this proof. Most of the time there isn't one that's just 1 or 2 steps. It's a bit more like this one. Alright, now time for the sponge. So given that line A is parallel to line B, prove that angle 1 is congruent to angle 3. So write a 2-column proof, write your statements, write your reasons, and end up proving that angle 1 is congruent to angle 3. That's it for this video. Once again, please make sure to take notes on the entire lesson. Make sure to go back and rank yourself on how you do on the sponge. Remember, you need to attempt the sponge to get full credit. There are still some people who are not attempting the sponge. You need to do it, or you won't get full credit. Please make sure you take a picture of all of your notes, send them to Doodle Classroom, and have a good night.